Hey everyone, welcome to the channel. Today we're diving deep into the history of asteroid impacts on our planet. From massive extinction events to the very geology that shapes our world, we'll explore some of the most significant asteroid impacts and how they've left their mark on Earth. We'll also discuss the science behind asteroid detection and planetary defense. Stay tuned to learn about the cutting-edge technology and international collaborations working to protect us from future asteroid threats. Let's rewind the clock about 66 million years. Picture this: a 6-mile wide rock, an asteroid larger than Mount Everest, hurtling towards Earth at tens of thousands of miles per hour. This was the Chicxulub impactor, on a collision course with destiny. The impact site, near the Yucatan Peninsula in Mexico, became ground zero for an event so cataclysmic it makes a nuclear bomb look like a dropped firecracker. The energy released was equivalent to billions of Hiroshima bombs detonating simultaneously. Imagine the heat, the shock waves, the sheer force that instantly vaporized the asteroid and miles of Earth's crust. The impact triggered mega tsunamis, wildfires, and earthquakes that shook the planet for weeks. Billions of tons of vaporized rock and sulfur were ejected into the atmosphere, blocking out the sun and plunging Earth into a prolonged period of darkness and global cooling. This impact winter had a devastating effect on life on Earth. The dinosaurs, those magnificent creatures that had ruled the planet for over 180 million years, were wiped out. Along with them, nearly 3/4 of all plant and animal species vanished. From the ashes of this catastrophic event, new life emerged, eventually leading to the rise of mammals and ultimately us. Our next stop takes us to South Africa, home to the Vredefort Dome, the oldest and largest visible impact crater on Earth. This crater, or what's left of it after 2 billion years of erosion, is a staggering 185 miles in diameter. The impactor responsible for this massive scar on Earth's face is estimated to have been about 6 miles wide. The Vredefort impact occurred when life on Earth was in its infancy, consisting mostly of single-celled organisms. The immense energy released by the impact created a dome of molten rock that rose miles into the air. This dome eventually cooled and solidified, forming the distinctive concentric rings that we see today. The impact also created a massive basin that filled with seawater, creating a shallow inland sea that existed for millions of years. The Vredefort Dome is a testament to the incredible forces that have shaped our planet over billions of years. It also played a role in creating the conditions necessary for life to flourish. Our journey through Earth's impact history now takes us to North America, specifically Ontario, Canada. Here lies the Sudbury Basin, a crater 81 miles in diameter and 1.85 billion years old. The impactor that created this crater is estimated to have been about 9 miles wide, making it one of the largest to ever strike Earth. The impact released an unimaginable amount of energy, melting rock, triggering earthquakes, and unleashing tsunamis. The Sudbury Basin isn't just a reminder of a catastrophic event from the distant past. The impact melted and fractured the Earth's crust, releasing a treasure trove of minerals, including nickel, copper, platinum, and gold. The Sudbury Basin is one of the richest mining regions in the world, and its mineral wealth has played a significant role in the development of Canada's economy. The rocks and minerals found here provide scientists with a window into the past, allowing them to study the composition of the early atmosphere, the evolution of continents, and the emergence of life. Our next cosmic scar takes us back to Canada, this time to Quebec, where we find the Manicouagan Crater, a breathtaking ring-shaped lake that's 62 miles in diameter and approximately 215 million years old. When the impactor, estimated to be about 3 miles wide, slammed into Earth, it created a massive crater that eventually filled with water from melting glaciers and precipitation. The central peak of the crater, formed by the rebound of the Earth's crust after the impact, remained above water level, creating an island in the center of the lake. This unique geological formation gives Manicouagan Crater its distinctive ring shape and makes it one of the most recognizable impact craters on Earth. The Manicouagan impact occurred during the Triassic-Jurassic period, a time when dinosaurs were just beginning to diversify and spread across the globe. While the impact wasn't as cataclysmic as the Chicxulub event, it still had a significant impact on life on Earth. The impact triggered widespread wildfires, acid rain, and a period of global cooling. Today, the Manicouagan Crater is a popular tourist destination, attracting visitors from around the world who come to marvel at its unique geology and stunning scenery. Our cosmic journey now takes us to Siberia, Russia, home to the Popigai Crater, a 62-mile-wide scar dating back approximately 35 million years. The Popigai impactor, estimated to have been about 5 miles wide, slammed into a deposit of graphite, one of the purest forms of carbon. The intense heat and pressure generated by the impact transformed the graphite into something extraordinary: diamonds. These impact diamonds, also known as Lonsdaleite, are incredibly hard, even harder than the diamonds we typically think of. They possess unique properties that make them valuable for industrial applications, from cutting tools to high-pressure experiments. The Popigai Crater is estimated to contain trillions of carats of diamonds, making it one of the largest diamond deposits on Earth. However, due to its remote location and the challenging conditions, mining these diamonds is no easy feat. The Popigai Crater offers scientists a unique opportunity to study the effects of high-pressure shock waves on materials and the formation of impact diamonds. Our exploration of Earth's impact history now takes us to the eastern coast of the United States, where beneath the waters of Chesapeake Bay lies a hidden crater, a silent testament to a cosmic encounter that occurred some 35 million years ago. This crater, about 53 miles wide, formed when an impactor, estimated to have been about 2 miles wide, slammed into the shallow waters off the coast of what is now Virginia. Geologists discovered the Chesapeake Bay impact crater in the 1980s while drilling for oil and gas. They noticed unusual rock formations and mineral deposits that pointed to an impact event. Further studies, including seismic surveys and gravity mapping, confirmed the presence of the crater. The Chesapeake Bay impact had a significant impact on the region, triggering massive tsunamis, earthquakes, and widespread environmental changes. The impact also created the Chesapeake Bay itself, reshaping the coastline and creating the conditions for the unique ecosystem that exists today. The Chesapeake Bay impact crater is a reminder that even relatively small impacts can have a lasting impact on Earth's geology, environment, and life. Our final stop on this cosmic journey takes us back to Siberia, Russia, but this time to a more recent event, the Tunguska event of 1908. Unlike the massive craters we've explored so far, the Tunguska event didn't leave a gaping hole in the ground. On the morning of June 30th, 1908, a blinding light streaked across the Siberian sky, followed by an explosion that was heard thousands of miles away. The explosion, estimated to have been about 1,000 times more powerful than the atomic bomb dropped on Hiroshima, flattened over 800 square miles of forest, knocking down an estimated 80 million trees. The absence of a crater led scientists to believe that the object, likely a stony asteroid or a comet fragment, exploded in the atmosphere before it could hit the ground. This type of explosion, known as an airburst, occurs when a space object enters the Earth's atmosphere at high speed and explodes due to the intense heat and pressure. While an airburst might not leave a crater, the shockwave it generates can still cause widespread damage. The Tunguska event highlights the importance of ongoing asteroid monitoring programs and the development of planetary defense strategies to protect our planet from future impacts. From the extinction of the dinosaurs to the creation of diamond mines, asteroid impacts have shaped Earth's history and continue to remind us of the immense power of the cosmos. While catastrophic impacts like Chicxulub are rare, the threat from smaller asteroids and comets remains a real concern. Thanks to the tireless work of scientists, engineers, and policymakers around the world, we're developing the tools and technologies to detect, track, and even deflect potentially hazardous asteroids. So, as we look up at the night sky in awe and wonder, let's also remember the importance of understanding and mitigating the risks posed by our cosmic neighborhood.